Hello everyone, and from my side, my name is Argyrios Kyrgiazos. I'm a data science at CARTO, and in this webinar, I'll go through like a use cases on how we can use human mobility index to perform urban analytics and particularly space-time hotspot analysis by using CARTO Platform. Now, CARTO Platform is an end-to-end platform for cloud-native geospatial analytics. It consists of 6 components: the Data Explorer, where the users can explore the data, bring their data from their data warehouses or data lakes. The Builder, it's a tool to build maps of very large data sets. Workflows, a new component that we have, that you can produce pipelines with no code. And Analytic Toolbox, it's a set of functions in order to enhance the capabilities of existing data lakes and to bring more geospatial functionalities there. Data Observatory, we have this huge catalog of geospatial data that you can access through CARTO, and applications, custom applications. CARTO can connect to the 5 major data warehouses: BigQuery, Snowflake, Amazon Shift, Redshift, Databricks, and Postgres. And we can build connections, and then we can write, read the data, build maps without having to move your data anywhere else. Now, the agenda of today's talk is, first I will do like a brief introduction. Okay, what we're going to talk a bit of data sets, about space-time data sets and urban analytics and what we want to do. Then the methodology, how we did what we did. Then I'm gonna show you some results, some live maps. There's going to be some live demonstration. And at the end, I will leave you like 15 minutes for questions, if any. So, yep, I think. So how we can use spatial data in order to provide innovative solutions for urban areas. Right now, urban analytics, they're getting a lot of attentions, for planning, for transportation, for a number of reasons. And their usefulness have been proved a lot. More and more, like local authorities, they try to use urban analytics in order to enhance their everyday, their day-to-day like work or planning or whatever. And here I'm going to show you and try to illustrate you like how we can use spatial data and then provide something, a solution that could be beneficial for urban areas. Now, some data sources that could be used for that purpose can be divided into physical and digital, and commerce on one axis, and then commerce and people on the other axis. So in terms of urban areas and urban analytics, so if we want to find, okay, which areas are like the trendy areas where people tend to gather, like what happens in one area, what happens in the other area, any type of segmentation, we can use like data sets such as POIs. I mean, this is a very well-known like points of interest categorized by classes and industry groups. We can use demographics, some basic socio-demographic and socioeconomic attributes, for example, the population, the number of females, the number of males, and so on, different ages. Financial data, then basically we try to find, okay, how much like the evolution of credit card spends and the number of transactions in specific areas, and also through time. And this is very useful for retailing. And of course, behavioral data, like, okay, audiences and geosocial segments, behavioral segments based on the analysis of social media. So in some areas, people tend to talk more about specific subjects rather than other subjects. And of course, this can be really useful in targeting like the audience. And of course, this relates to urban analytics by, okay, how to use this information in order to design something that would be really helpful in the decision making process. But I'm not going to talk about these data sources today. Now, what it has been proven in the lately and in the past couple of years, like with all the technology emerging and so on, is that the intersection of big data and mobility insights offer unprecedented opportunities to address these challenges. Now, most of the data, I would say circa 80%, they have a spatial component. And we can say that close to 100, they have a temporal dimension. So we have data that behaves that they vary in these two different domains, like space and time domain. And we're talking about space-time dataset. And human mobility is one of these. Now, what is human mobility and why it is very important? Human mobility is how people move from one location to another. So how many people visit one area, how many people leave from one area and move to another. So human mobility data is using anonymized and aggregated mobility data, and then they're delivered in a format that you can use. Usually it is aggregated per like a unit area and per a specific frequency. Now, it is aggregated, of course, for a number of the reasons. First is to make up for insights, because you have locations that you have like 1 or 2 users there, 1, 2 people, and this doesn't bring, but of course to comply with GDPR. And in time domain, the aggregation, it depends on the kind of the data that you have. It can be daily, it can be weekly, monthly, and so on. Now, the data set that I'll be using today in this presentation is of Unicast data, human mobility trends. Now, this is an index that it's built from raw SDK data, and these data are scaled by using demographics in order to scale to the actual population moving from one area to another. And this data set like consists of monthly normalized traffic index, footfall traffic index. And we have like 2 dimensions, as I said, space and time. So this index, by being scaled by the demographics, allows someone to make a comparison in time, but also in Spain. For example, for one specific location, we can compare like 2 points in time. So we can compare like 1 point in 2021, August, and another one in January 2021, I mean, for the same location. And then based on this index, we can say, for example, if it was 1/4, like the January, it was 1/4 of the August 2021, then we can say that August had more times more footfall traffic than the January one. But also it allows to do a comparison between 2 locations at the same time. Now, let's say that I have location A and location B, and location A experienced 4 times more footfall than location B. Then basically this index will be 4 times than the location B. And by extrapolation, this allows also comparison between like points, different points in different times. So it's a really useful data set that can help us like identify how people move. And this is particularly very interesting in the urban areas where like most of the congestion happens, most of the people that tend to move. And these are the areas that we need to like to find solutions to do a better planning. Now, this is how it looks like. Now, this particular data set was for the whole UK, but it's being used here. So it covers the whole UK, and the data, the raw SDK, they're aggregated at quad key, which is like the gridded system, at resolution 15. And this means that around the equator, we're talking about like rectangulars of 500 meters by 500 meters. This is like what resolution 15 translates to dimensions in space. So here you can see like one example, like what is this traffic index, how it varies like between different periods. So we have January 2021, we have February 2021 and March 2021. For the city of London, for the center of London, then we can see like, okay, how it differs from time to time. Now, these are monthly data, but we can see that January and February, they're different. But also the same apply for February and March. So on top of that, so as I said, we have all this data set, all this data for the whole UK. Now, we couple it with another data set which is available through CARTO's data observatory, and it's called Urbanity. Why we do that? Now, what Urbanity is, Urbanity gives you a classification of each quad key cell, and the classification is one of the 6. It can either be remote, where basically areas with very low population, not easily accessible by the main road network, rural areas, areas that have very low population, but still accessibility via the main road infrastructure is doable, low density urban, medium density, high density, and very high density urban areas. So we have these 6 classifications. Now, because most of the areas in the country, they're either remote or rural areas, this doesn't really bring any benefits. So we couple the human mobility dataset with the urban levels, and then basically we filter for the last 4 categories. So we keep only the locations that imply some density, some urban density. So from small, medium towns and bigger. So in that way, we can isolate all the areas that are urban. So here you can see one map, and then I'll go to the actual map just to show you how it looks like. Now, as I said, this is, by the way, this map is built in CARTO Builder, and on the left side, we can see the human mobility index. As you can see, the values, they go up like to hundreds of thousands, and then basically this means population. But of course, this is like aggregated now at higher resolution. And on the right hand side, then you can see the classification of urbanity. Now, for example, if we take as an example the city of London, in the center, you can see that we have very high density urban areas. Then as we go to the outskirts, the purple one becomes high density, then medium density, and then low density. So this is the original dataset that we have, the human mobility index, and then you can see for remote areas here, you can see like a traffic index, meaning that people visiting this area, the average, this is the average for like, we have this dataset from September 219 until September 2022. So this is the average, and basically this index means that in this location, average per month in this duration, you have that 790 people visit this area, which is a very low number, I mean, meaning for a month. So we use this in intersection with the urbanity, and then we can isolate the urban areas in order to conduct the hotspot analysis, as I said at the beginning. Now, of course, here we can also filter, and then we can keep like the areas, see, okay, what are the areas that are very high density urban and high density urban, and then by coupling these two, then we can keep only the data that is required. Now, going back to the presentation, and so as I said, the aim, the objective of this study is to use the human mobility index data and then run hotspot analysis to go to the urban areas and find, okay, what are the locations and what are the months that appear to be hotspots or cold spots, whatever is more, whatever is interesting to everyone. So we want to identify locations that appear like to have increased visitation compared with the bigger picture of what happens with the other areas, with the neighboring areas, and so on, so that we can identify areas like, okay, what are the areas in London that appears to be, when these areas tend to become hotspots? Do we detect any seasonality? Do we detect any pattern, spatial or temporal pattern, that can help us in order to perform better decision making? So in order to do that, and in order to do that effectively, we need to do like some clustering. Like clustering hotspot, it's just one approach. Now, how we can do this, and how we can do this at scale, at a very granular level. Now, as I told you before, like it is because it is for the whole country, and it is at a resolution of 500 by 500 meters, like for every month throughout the period of 2.5 years. So we have a lot of data set. Now, regarding the hotspot algorithms that can help us identify and measure the strength of spatial patterns by taking like the neighbors around its location and calculate whether like something is a hotspot or not. Usually we use two statistical tools, which are very common in literature: GTIS and Moran-Tsai. Now, GTIS, I mean, they tend like to do the same thing, but they try like to, they talk about something different, which I'm going to explain. So GTIS, basically, it tries to find like areas that they're hotspots or cold spots across with what happened in the whole data set. So in that particular case, what happens in across the whole area. So as you can see here on the left-hand picture, so this detects the hotspots neighborhoods and the cold spots neighbors across the whole area of interest that we're examining. Now, in the GTIS, one location during the calculation is being taken into account. Now, the other one, the Moran-Tsai, basically, what it does, it takes out itself. So for example, if you have this neighbor and then you want to examine what happens here in the middle, then it takes out of itself, I mean, this cell in the center, it takes it out, it does like, does the computation as it was done with during the GTIS, like of the neighborhood, how it performs with respect to the whole area of interest, and then it checks how this particular point behaves regarding to its with reference to its neighborhood. So in that way, we can identify locations like outliers location with local Moran time, like low, where you have like a low observations, but the neighborhood is high, or the opposite, where you have like a high observation, but you have low, but the neighborhood appears to have like low observations, whatever this observation is, whatever this feature is. Now, these metrics, these statistical tools, they're very common in the literature, and they're very, very, very useful, and can help you really easily identify patterns, and patterns that can lead to great insights and then maybe to some very good decisions. Now, here we concentrate on the GTIS GI statistic. And what we do is we expand it in time domain. Now, the original GTIS was designed like for space, taking account also only the space. Now, the GTIS GI statistic is a Z-score. Okay, it's already a Z-score. And this is the formula that you can see here on the left side. Now, the W, the X, Y, and the XJ, these are like the feature. And in this particular scenario, it is the human mobility index. And the W is the weight matrix. And then this weight matrix basically shows like, based on the neighborhood, what is like the weight that a neighborhood would account for a desired cell. Now, if we want to expand this also to include the time domain, there's like two ways, which are depicted on the right hand side. So way one is, okay, for each focus cell, we can use the past and the future value of this cell. So for example, if we're talking about February 2021 for one cell, let's call it cell A, then for the time domain, we use like January 21 and March 21. We use these values. But also, another way is to include, which you can see on the bottom here, is where you can include future past values, but also of the neighborhood. Now, we use the latter one. So basically, here in this equation, the interactions between the neighborhood in time, but also the neighbors in time domain are the neighboring cells and the cell itself in t-1, t-2, whatever like the bandwidth we choose to be. So what someone needs to do is basically include more observation and then change the weight here. Like instead of being in 2 dimensions, now it has to be in 3 dimensions. And this is done like by doing like an extension from only space, as you can see here, going into a space and time cube. So you can have like your cells as you had them, but now you add an extra layer. In this particular case, it is time and the month of the year. So basically you have your observations like one, like for different cells, but also this extends like for the different months of the year on the vertical axis. So you can see like March to April, this is a picture. April to May, this is a picture. This is what we see in May to June. So it works on the same way as before, but now from like a rectangular, let's say we go to a cube. And we need to aggregate the information into space-time bins. And so instead of having like only the spatial index, like quad key, now we have quad key and the daytime. So we go one level. So we increase the dimension by 1. Now, maybe this sounds complicated, but it's not so much. It's like how you store and how you save the information. And then this allows you, like, and especially when you work like with spatial index, it helps you a lot, like how you can structure your information and how you can access and then process it more efficiently. Now, but as I was saying, that it's how we can replicate all this at scale. I mean, it's good, like, okay, let's go for the city of London or for the city of Birmingham or for any other city. And then I gather this information that I have the mobility index, the human mobility index for the location, but also through time. But if I want to run this for a whole country, how I can do this efficiently? Now, for that purpose, we use Spatial SQL. In particular, we use the analytic toolbox in the workflows from CARTO. And we try to exploit the spatial gridded system in order to perform the operation more efficiently. Now, one of the advantages of a gridded system is that you don't need to perform the complicated and the computationally expensive geospatial operations. And you can work with strings, you can work like with indexes, either it is integer or a string, and then you can know like from one location which are the neighbors based on the index, and then based on how far you want to go away from like from your focus cell. And this is really like game changing on how you can process this data at a very large scale at the country level. Now, in this particular scenario, as I said, that we have the human mobility index, like at quad key resolution 15. We have like a timestamp, which is the month of the year. And then we have the human mobility index, which is the foot traffic index. And this is a numeric value. So we have this information, we filter it with Urbanity in order to keep only the locations that are like urban location and filter out the rural and the remote areas. And doing that, we can run the space-time Getty sort at scale for a whole country within minutes. Now, CARTO SpaceTime hotspot analysis is a stored procedure that basically takes as an input like one table, which is dataset, which has to have the quad bin, has to have the datetime and the value that we want to do. You specify the output table where you want to store the information, and then it has like some parameters that the user needs to set. For example, what is the index, what is the column with the index, what is the column of the datetime, and what is the value that you want to run like the space-time hotspot analysis on the feature. Then it is like the neighborhood, so how many layers outside you want to be considered as neighbors, and the time frequency. So in this particular, we have month, and then we want to consider like the two pasts months as an indicator. And we use also like a kernel, like a decay functions. So the further, like in space, the further a user is, the less influence it has. And also in time, the further in time like an observation is, the less influence it is. So this is like the function of analytic toolbox to run the space-time GTIS. And this is CARTO's analytic toolbox. Now, this is a function. So if someone wants like to use CARTO and this functionality, this is the function that it should look for. And then it passes the information, and then it can get like the output at this table. But as I told you before at the beginning, like CARTO has like a workflow which is like design of pipelines with no code. So basically you bring your information, your table, you drag like the components, and then you design the pipeline. So you don't need to write any SQL code, you don't need to do any of that. And I will show you one example how it looks like here. You can see like a screenshot, but I will show you actually the pipeline, how is like the workflows. So for this particular workflow, and if we want to run this analysis, this is all what someone needs to do. So here is the table that contains the filtered human mobility index filtered by using like the Urbanity, and then we feed this data set into this component which is called GTIS spacetime. We specify the index column, the date column, the column that we want, like the feature that we want to run the hotspot analysis, in this particular case, traffic index, and then the kernel for the spatial weights, for the temporal, the size, temporal bandwidth, and the time interval. So we specify all this, and then basically this will consume this human mobility index dataset. It will run the analysis of the space-time GTIS, and the output will be stored in a temporal table. Now, in this table, what we do further in order to identify the hotspots, because we want, in this particular case, we're interested in order to identify the hotspots in space and time. So what we do, we say, and again, as I told you, that the GTIS is a z-score. So based on this z-score, we can get like a p-value. So in this particular scenario, we choose like, okay, keep only the observations that have a p-value of less than 5%. And on top of that, okay, from those, keep these observations that have a value greater than 0. So the z-score is greater than 0 and the p-value is less than 5%. So this means that we keep the locations that we are 95% confident that they're hotspots. Okay, and then basically we flag them. So we flag them, and then we store this analysis into a table, and that's it. It's so easy like to perform all this analysis without the need of writing any complicated code or SQL. Just with no code, like bringing components, someone can do this analysis. Now, moving back to the presentation. So we have done this, and then we go and see, okay, how it looks like. So based on that, based on the output, we build a map where basically right now we visualize the z-score of the space-time hotspot analysis on a map. So we go up, yeah, and then we see that, okay, which were the locations that have been kept. So we can see here that these are the locations here on the map. What you see is basically the location, the urban locations that have been filtered first by using the Urbanity dataset. And then what we see here is the average GTIS GI statistic for each location. Okay, now by zooming in into like a specific location, let's go to the city of Reading, for example, for no particular reason, just like as an example, without losing any, like without loss of any generality and so on. Now, what we see here basically is that we see that the center here of Reading, the average value, and this is like throughout the year, basically it has like some values of like 7, 8, or 9. And this is the average GI that it has over time. And this means that basically this area is a hotspot, like more or less. Now, on the figure below, we see what is the projection of the number of the hotspots. If you remember previously here that we do some filtering and then we flag some locations and hotspots, they have a p-value, each location in space and time has a p-value less than 5% and a g-value greater than 0, and it's be flagged as like as a hotspot. So here we see, for what we see here in the map, okay, what is the number of the hotspots? Now, here we see the progression through time. Now, one very interesting thing is that we see that at the beginning of 2020, the number of the hotspots start decreasing, and we all know why right now, due to COVID, and then it goes back. And basically, here we can see only on the map, only we can see space, but coupling it with a widget in time here, we can identify some seasonality. So if I further zoom in, we can see like, okay, how many hotspots we have and how this behaves in time. In addition to that, we can add also widgets or parameters that basically we can keep like, we can go up like for the whole duration of the analysis. Now, before I had it until 2019 and 2020. Now, if we expand it, like to give it like a few seconds just to refresh itself, we can see the progression that it happens through all the study period. And then we can identify like seasonalities. We can further zoom in into some locations if we're interested. We can see here that after that, this area regarding like the hotspot becomes stable. Now, if we go like into another location, let's say that we go to Guildford, Surrey. Now we get like some locations, and then until the time series widget updates, then we will see what's happening. Then we see like the center here of Guildford being like a hot area. Of course, there is a university here and so on. And the surroundings that tend to be like less, or that don't tend to be a hotspot, actually. And if we want like only to keep some locations, we can further like filter it here. So, okay, keep only the observations that they have a value greater than 8. Now, what we see here, we see these funny shapes. We see that in 2020 there was a drop and goes a bit up, then pretty much stable, and then in 2022 it goes up again. Then this is during January and February, and then it goes back to the normal. But here we tend to see lower values, but of course a GA value of 3 means that we're already like 90% like confident that this is a hotspot. But again, this example was run and this demo was run for the whole country. So what we consider here, basically it's like one location with the average what happens with the country. Someone could go and focus, zoom into a particular area and use data for that only area. Even granular than that, like go to resolution 18 or to resolution 20. It depends on the data that someone has. But this is like a tool which, when combined with human mobility data, it can bring very interesting like insights, because we can identify like how people tend like to visit these areas. And if we go to the south of UK, if we go to the beach, for example, Brighton, I'm pretty sure for that we will see some peaks here in terms like of hotspots during the summer, during the hot seasons. And of course, this is implicit that, okay, you go to the coast side area and then you identify like that during the summer you have more visitors. But sometimes you don't know like by how much. For example, okay, here when we see is December, so on. So yeah, well, in this particular case, there is no difference. But before that, like in 2020 and 2019, like it tends to get like the higher values during September, August, and so on. And again here, yeah, October. Okay. Now, but bear in mind that you can use any other data set, like not on monthly level, even on daily level, and then you can run this analysis and identify some patterns. And then this also can be used like from different kind of industries, not just for rural planning, but also from insurance and so on, finding like, okay, what happens with the area? Like, is there like any drop in the visitation in this area? Is something that goes wrong? Real estate, I mean, can really use this type of analysis and this kind of data to identify like locations that people start going there. Now, the output of this analysis is a cell allocation, it's a time, and it's a value. Okay, and this shows you like how hot or cold this area is in terms with the feature. Now, in this particular case, we have a traffic index. So this means that one location is visited more in this during this month or less. Now, maybe we have like something else that it will mean something totally different, but it's a really useful tool that can be run and then it can bring really useful insights. So for example, here by identifying the locations and the times that something happens can help, for example, in better like planning or finding like having the parking space available for the people who visit, for example, Brighton, which areas tend to visit. So transportation can become more frequent and specific seasons. This can be really useful to local authorities or any other like party that wants like to do something. Even real estate, like they want to find, okay, I start seeing that this particular area here like start become more trendy, so more and more people starting visiting. So this means that this is a developing area, so maybe it's really good for investment. There's so many cases that this could be helpful that right now I'm only highlighting very few. Now this is like the conclusion of my presentation today. And as a summary, basically, I presented like how we can use human mobility index to run a space-time hotspot analysis by using CARTO, and how we can do this at scale very easily and with no like writing actually any code, just using the components of the workflow. So with that, we can get very useful insights for the areas. We can see like, okay, what are the visitation patterns in space and time, and how these can be used for better planning and better decision making applications. So thank you very much everyone for attending this webinar.